This is the worked examples video for orbital speed. By the end, you'll be able to do three things. First, use v equals 2 pi r over t. Second, rearrange it to find the radius or the period. And third, keep the units consistent. Here's the equation: orbital speed v equals 2 pi r over t. V is the orbital speed in meters per second, and r is the radius of the orbit in meters. T is the orbital period, the time for one complete orbit, and it must be in seconds. The trickiest part of these questions is usually converting the time into seconds first. Let's work one through. A satellite orbits at a radius of 8,000 kilometers, taking 6,000 seconds for one orbit. Find its speed. Write the equation v equals 2 pi r over t. First, convert the radius to meters. 8,000 kilometers is 8 million meters. Then it's 2 times pi times 8 million, divided by 6,000. That works out at about 8,400 meters per second, a typical speed for a satellite. Now a rearrangement. A moon orbits at a radius of 4 times 10 to the 8 meters at a speed of 1,000 meters per second. Find its orbital period. Rearrange for t. The period equals 2πr divided by v. Substitute 2 times pi times 4 times 10 to the 8, all divided by 1,000. That gives about 2.5 million seconds, which is roughly a month. So the maths matches real moons. Now it's your turn. Try these practice questions. Question 1. A planet orbits at r, 5x, 10, 10 m's, t, 2x10, so 7s. Find its speed. Question 2. Convert 10,000 kilotons to meters for use in the equation. Question 3. A satellite r, 7 to 10, 6m, v, 7,000 mcs. Find t. Use 2 pi r v. Pause the video, work them out on paper, then play on to check your answers. 3, 2, 1. Here are the answers. Number 1, approx 15, 700 nms, v, 2, pir, she, t. Number 2, 10,000 as, sius nouns, we 10, sius 7. Number 3, approx 6300 s, t, sius 2, pir, v. Thanks for watching. If this video helped, please give it a like and subscribe to the channel for more IGCSE science revision. My revision workbook is available from the link in the comments.